Welcome, everybody. Good morning, good afternoon, good evening to wherever you're watching this from. I'm going to talk today about GraphQL and why we should use it, or why is it gaining so much popularity in the web world or with technologies. When you need to build an API, your mind generally jumps towards REST. It's essentially like the standard for designing web APIs, considered kind of like the de facto standard when you like deploy APIs or developer platforms usually. With REST, we have seen great ideas, something like stateless servers or like structured access to resources. But we've also seen that REST APIs have been like inflexible at times to keep up with, say, rapidly changing client requirements. And we'll see more examples as we go along in the slides. But usually when you're building like a web app or like a customer facing site, data performance and reducing the number of data round trips that happen with your data directly impact user experience. Have you ever been on, like, say, one bar of service and always frustrated that things are not working and you're not getting like information back based on the app that you're using on a mobile phone, or just playing around with the website on a slow, laggy connection? That's where GraphQL can help. And before I jump into what GraphQL is and why we should use it, I just wanted to give a background on who I am, what I do. So I'm Aditya Gidh. I'm a software engineer at IBM Research, and I'm part of the team that builds apps at Research. A couple of my colleagues presented this morning on different presenting on like IO Polyglot on using APIs using different languages. So you can check back that recording if you like GraphQL and if you want to design an API in other three languages apart from GraphQL. And I've been working on full stack development and DevOps engineering during my time at IBM. And I've worked across different teams in IBM, from like customer facing teams to, say, product facing sites and so on. So let's look at what is GraphQL. To start with, it's gaining popularity and it's deemed as the successor to like REST APIs. It's a specification which was introduced by Facebook, now called Meta, and it's a query language for APIs and runtime for fulfilling those queries with your existing data. What we mean by that is GraphQL helps you to solve the common challenges that developers face when you build REST APIs. And it's almost like a better way to do APIs depending on your use case. And what I mean by that is it puts all your data in one place, and we'll see more why it puts it in one place. It helps to decouple your apps from your services. So you have your client and your server evolving on its own without all the costly entanglement. And it helps you to build great experience faster with less code. So what we can think about GraphQL is it's technically like a layer between your front end and the back end. And the client will request like data from your API, and GraphQL will decide on what to return and how much to return, depending on the requirement. So that's what I mean by like picking up selective information from your endpoints. So one distinction that I want to highlight between like query languages and GraphQL is that usually we have query languages existing between a backend and a database. But with GraphQL, it exists as a layer between the front end and the backend. So the main goal behind like designing GraphQL was to make the query smarter. And because it sits between, say, client and backend services, you can aggregate multiple resource requests into a single query. And what we mean by query, what we mean by multiple requests, we'll see as we go along in the slides. But I want to clear up some misconceptions on what GraphQL is not, because it's easy to confuse GraphQL with a lot of things. So GraphQL is not a client-side state management solution. Quite often you have the client applications which need to perform some sort of state management, or even like caching or, say, cross-page consistency. But GraphQL is none of these technologies. So it's not going to be replacing things like Redux or Relay. And people also confuse it with Facebook's third-party API, which is their REST API, but it is nowhere close to their Graph API. It's entirely different. Also, GraphQL is not like limited to specific databases, because you have very few restrictions on the backend, and it can be used as a memory cache or used with a memory cache with, like, say, relational stores or non-relational stores. because the fields that are selected into the document are just functions. And we'll know more about these functions, which would be called as resolvers, which get computed on the fly. And GraphQL is also not limited to the JavaScript ecosystem. This is because we have seen many mature implementations of GraphQL servers in like a variety of different languages, ranging from Java, Python, Rust, C Sharp, Go, even Ruby for that matter. And GraphQL is not limited to be used with React or web technologies. You can build like a command line application with GraphQL, or you can also use it with XML HTTP requests. Also, it's easy to confuse GraphQL with graph databases since it has graph in its name, but it is nowhere related to graph databases. The naming does make it confusing, but there are like no similarities between graph databases and GraphQL. The graph in GraphQL simply means that our queries are now able to crawl that endpoint and pick up selective information as a result of it. So now we know on what GraphQL is and what it is not. We can talk more on why we should use it. So GraphQL is compositional. What I mean by that is a GraphQL query itself is kind of like a hierarchical set of fields. You shape a query exactly based on the data you want to return. A GraphQL is declarative, wherein query responses will be decided by the client rather than the server. So you have no cases of, say, underfetching or overfetching data because you're going to get the data that you requested for instead of getting multiple things returned to you by the server. So that helps in reducing network requests because nested data can be retrieved in one query. So you're reducing network requests as a result of it. And GraphQL comes up with a type data schema. This is really helpful when you are developing an application because every item fields will have to make certain types. And this makes your data really consistent, very manageable. And I mean, it's the schema that GraphQL queries essentially. You're getting results based on the schema that you defined previously. And GraphQL also helps to support pagination without any unnecessary overhead. Now, looking at a simple example. In this example, imagine like an application wherein you have books and authors as the two resources. And think of it like these resources have like 15 fields in them. So you could have a book with a name, description, page count, ISBN, say book cover, and so on and so forth. And you could have the same for authors. Now, as a part of this problem, I want to get all the authors and their names and all of the books for those authors and just need the name of those books. It sounds like a difficult nested query that we're trying to get, but let's look at it from a RESTful approach. We would have multiple endpoints to begin with. And at first, we would say hit /authors, wherein we get information about the author with like ID, name, and like a bunch of extra information, which is probably not needed in our problem currently. Now, once we have the list of authors, we would take ID for that every author, hit a different endpoint, which would be say /authors :ID/books. And we'll call the server again to get the books for that author. Now think of retrieving 5 authors this time. We'll be calling the API 5 more times to get the books for that author. And every time we call the API, we're getting in more information back for the books than we actually need for our problem. On the right-hand side, this is the way a query in GraphQL works. With GraphQL, you compose a query of exactly the data that you need. You will notice that right off the bat that it bears resemblance to JSON without the values, and that's very much on purpose. And I'll demo more as we go along through the queries or understanding what every word in this query means. So here we are looking at getting a list of authors and their names and a list of all their books and their names without any extra information. And this simple query gets all that nested data for you in one single query instead of making multiple queries via RESTful endpoints. Now let's compare GraphQL to REST I mean, we don't want to replace one technology over the other, or we don't want to like add like a scoring mechanism or like a keep a scorecard on what does better over like REST or GraphQL. But we're just making this understandable on our side on what could be used and where. So if I have to compare, say, GraphQL and REST, I'll try to put this in an analogy referencing restaurants. So REST could be thought of as self-serving restaurants, wherein you could think of it like a buffet. You get up from your table, go to an individual table, get your salads, get your desserts, entrees, appetizers, like going to individual resources. Whereas GraphQL could be thought of as a restaurant wherein you have a huge menu, but you're filtering out certain items, and this restaurant is served by servers. So you're filtering out items in the menu and requesting them via your server. The server goes and gets them and delivers it to your table. So it helps with data fetching in this case. In GraphQL, you just are specifying data with a single API call. And that single API call is to an endpoint called as /GraphQL. Whereas in REST, you have fixed data with multiple API calls. And in the last example, as we saw, we created different endpoints like /author, /books, for example, to get like answer to a problem. So you have multiple endpoints versus single endpoint for GraphQL. So this helps with like sending a complex query wherein you're trying to fetch additional data according to the relationships that are defined in the schema. And doing the same thing in REST would be kind of complicated because your client will have to send multiple requests to get like that nested data for your like purpose. This leads to a problem wherein you're trying to make multiple requests. So you're making n+1 queries, for example. With GraphQL, you have things called as resolvers, whereas with REST, you have route handlers. So in REST, every request will generally call, say, one route handler function, for example. Whereas in GraphQL, you will have one query which can call multiple resolvers to construct like a nested response, which can return multiple resources. And the conceptual model on REST versus GraphQL is with REST, it's resources, whereas with GraphQL, it's a collection of nodes and edges called it's graph, wherein it's a collection of nodes and edges which relate those nodes. And on every node, you have scalar properties, which could be like int, string, bool, and so on. Let's look at some GraphQL basics now. The most important thing with GraphQL is a schema. You need a schema to describe the data that the clients need. Then you have resolvers. A resolver is a function or a method which resolves a value for a type of field within a schema. And a resolver is a key architectural component which connects GraphQL fields, GraphQL edges, queries, mutations, and subscriptions to respective data sources. Just gonna get some water, sorry about that. The next thing in GraphQL is a query. A query conceptually models a read, wherein a client is trying to send a request to the server and the server responds with a single response. This could be thought of as, say, GET request in REST, wherein you're trying to fetch and read data. Mutations are GraphQL's way of applying data modifications to resources. This could be thought of as CRUD operations in your REST API, wherein you are creating, updating, and deleting data with like different mutations. Subscriptions are GraphQL's way of clients to receive notifications and data modifications, wherein you're modeling an event observation. So the client will specify a GraphQL document that is to be re-executed whenever an event occurs. And the response to the execution is pushed back to the client, like when you have a persistent connection. So query and mutation are stateless. So these can operate in like any transport layer which supports like the request response model, but subscriptions are stateful. Also, one important thing to note that is it's not mandatory to have all these operations supported as a part of a GraphQL query. These are basically just like semantic declarations, which help you communicate the intent when you're trying to design an API. As I talked before, we were looking at a query before, but now let's look at in depth on what every word means when we are like looking at a query in GraphQL. So what we're looking here is a query document, and this contains valid GraphQL text. Now inside the slide here, we have a bunch of text which resembles JSON, and we send one of these to the server, and if everything goes well, we get a JSON return back. This is defined as a GraphQL document. So the first thing when the server sends this document, the server tries to parse and validate it. This query, if it's valid, the server will try to attempt and execute it. If it is not valid, if you're missing like a curly brace, for example, or if it is not syntactically valid GraphQL document, then the server can detect it and not execute it. Looking at the query keyword here, this is called the operation type. It's usually the first keyword that you see in a GraphQL document. And usually this will be like a query, mutation, or subscription based on the basics that we saw in the previous slide. Now here we are trying to execute a query for like getting books for all authors, whereas wherein get books for authors is the operation name. Now this name is optional in some cases, but I mean having it here is pretty useful because it helps with say debugging on what query failed, or it helps with documentation, as we'll see more once we like execute some queries in our demo, and identifying which operation failed when you like try to send multiple GraphQL documents. Then we have an ID here. This is called as a variable. It helps in making your GraphQL documents more reusable. So in this case, we're just trying to put ID as a variable wherein we can like fetch any author we want, as long as we know the ID. And all of this is just one request in GraphQL, wherein we're trying to get books and author information in like a single query. I mean, this is so much nested information we're trying to get, and GraphQL does it in one single query. Now, if we still feel that, okay, we're getting a lot of information than we actually need, then we can just offer like a sub-selection of information. So the query on the right is the same exact query, just getting the fields and the information that you actually need for your purpose. And it's like so easy to get nested information from a single HTTP request rather than sending multiple requests using RESTful design. Let's look at some of the benefits of GraphQL. So as I spoke before, it has a single endpoint, and data exchange happens only from a single endpoint. So with network speeds, I mean, when you're trying to design an application, be it a mobile app, be it a web app, or like a website, I mean, network speeds affect everybody. So overfetching or underfetching data at times have the ability to like make your request more inefficient. And this is directly beneficial to your end user experience. If the request is efficient, then your experience is going to benefit as a result out of it. So as a part of the single endpoint, you can just make one query, get your information back and display it on your mobile app, for example. Other benefits that GraphQL offers is declarative schemas with type safety and data formats. Since it's a strongly typed language where each level of a GraphQL query corresponds to a particular type, we have a properly defined schema that way. And through this schema, GraphQL helps providing type safety for our requests. And this helps with, say, predictability when you're trying to get a response back based on the query that you send in, because you're going to get data back in the same exact format for the schema that you specified in. GraphQL is also dynamic, which helps with, say, less data fetching, which is directly useful towards lowering your data transfer costs and helping with faster application load times, or even making your app work better with slow internet connections. Now, GraphQL, it also offers integrations with client libraries. So you can integrate it with the React applications, and it's really going to help to improve the experience for the app, because with React, you're just going to load things, or you're going to load things in the view based on the data that you need. So you're just trying to load, say, statistics for a player when you're trying to like emulate their goal scored and assist in like the latest World Cup that they had in soccer. And you're just going to present that information very quickly in the view by getting all that nested data together. So GraphQL can be like exciting new technology, but it's like important to understand like certain trade-off before like we jump to making architectural decisions. And we'll look at some demos now wherein we can see how these queries and mutations work together. Hope you can see my screen wherein I'm showcasing VS Code now. And this is a sample node project wherein we are trying to get, we're trying to run some queries and mutations as a part of our demo. And I started this project using npm init, wherein this command is like to initialize a new package, a new project. It'll ask you some predefined questions and it generates like a package.json, which is your metadata for the project. And the two important libraries that we use here is Express and Express GraphQL. So I did like npm install Express and Express GraphQL before I actually started this project. And since I already have these packages installed, I'm not going to install them again. But Express GraphQL is like the Express server that runs the GraphQL API. We don't have any scripts as of now or any dev dependencies. We are just going to look at a simple example wherein I've created a sample, a Node Express server, wherein we're trying to define a schema. So as of now, when we start, we import Express because that's what we want the app to run on. We're running it on port 3000, and we're using Express GraphQL server to run our GraphQL API on. Now here we see a line which corresponds to schema. As we spoke in the slides, a schema is something like a type definition. So jumping into the file itself, here we're importing GraphQL, and we have different types imported in as well, which conform to our schema. And as you can see here, I'm just using like some fake data here. It's dummy data for like JSON values, easy for demo purposes. I mean, if you have a database, you'll have an ORM layer and that'll like take care of like all of this. So this is users data from like a mock data file. It has about say 1000 rows and just like dummy fake data. So we're not leaking any information for a person. So we have that schema built in. Going into the schema again, we're pulling in all the scalar types like we talked about with int, string, and GraphQL list as well, wherein we want to return a user list for getting all the users. Then we are pulling in our mock data. And then we talked about types. Looking at types themselves, here we have a user type. So we have a schema which conforms to a type user. And here we have information on like fields associated with the user, wherein we have username, wherein we have a type name user, and we have fields called as ID, first name, last name, email, gender, employer, location, etc. So these conform to a user schema type. And once we request information from GraphQL, GraphQL is going to return us back information on these fields only because these are the only fields that are defined in the schema. Going into the schema file again. Now we define something called as query, wherein we're trying to give it a GraphQL object type, give it a name called as query. And as a part of this simple query, we're just running in a query wherein we want to fetch all users as a part of our mock data. And resolve is something like a resolver wherein these are like functions that are computed on the fly. As of now, since we are like getting in all the users, like a user list, we don't need to like specify any arguments as a part of our query. And we'll know more about what arguments mean in like the second example that I'll show. And as a part of the query, it's just like getting in all user data for that, for the query. So let's try to run this now. So since it's a Node project, I'm just going to do node example1.js. It starts my app on port 3000. And here, this is like a GraphQL interface wherein we are trying to get information on our queries and mutations. And this is just a mechanism to like visualize information about how GraphQL queries and mutations look when you're trying to execute them. The good part about this is it adds in the documentation automatically for you. So as a part of like a project now, I can go and see what queries exist as a part of my code base. Here we have get all users, which we saw previously, and we're getting a user list. And this is the type schema that we defined as a part of our code base. So a user list will have information about a user conforming to this data schema. To run this is simple. I just select this and I run it, and I get information back for all the users. This is all the users in the JSON document that I had, which is like fake data. Now, this is a simple example. What if I wanted to add a user to this document? Going into the code again, when I said add a user, this is like a create operation. So in GraphQL, it's called a mutation. So we define something like a mutation here, wherein we're giving it a GraphQL object type, and our mutation name is create user here. And the type that we want to return when we create a user is a type user. And in this case, we need to pass arguments because we need to post data in terms of REST thinking. So as a part of like adding in a new user, we're going to add all the fields which are conforming to the user schema. So we're adding in ID, first name, last name, so on and so forth. And this resolver function helps us to add this user into this user data list, wherein we're just going to append like a new user with the requested details. So let's try to execute this mutation. But before I do that, I just wanted to highlight that you have to export your GraphQL schema with a query and mutation that is defined up here. And this is what gets added in once the auto documentation is created up on the right here under schema and mutation. Now we're going to add a new user. What we're going to do is comment this out and uncomment this mutation. I already have like few values added in for like first name, last name, email, gender, like all of the fields that conform as a part of the user schema. I am going to run this mutation and it publishes data back to the user data. So I can see that the information that I passed through got entered into the user data object. And now I want to verify that if it actually got added in or not. So I'm going to comment this again. And because this is a simple query to get all users, I cannot query by ID or like name, but we look at that like querying by individual entity pieces in the next example. But like querying all the user data now, I am going to see if the data that I added was added in or not. And I actually see it being added. So this is like as simple as creating like a CRUD operation, which was like creating a user as a part of your GraphQL API. Moving on to the second example. So in this example, it's using the same data, but we're trying to build the schema in a different way, wherein we're trying to use things which are like very characteristic to GraphQL, wherein you have backticks coming in. So let's look at it from the top. We are importing Express, which is our server, and we're getting in Express GraphQL using GraphQL HTTP as a part of this module. And we're using build schema, which is different from our first example. Now, build schema is going to be like something in characteristic GraphQL language, wherein you're defining type and schema as a part of your build schema document. Using in the same user's data on the port 4000 now, just running in a different port here. So looking at the schema here, we have defined type query. And as a part of this example, we are going to have multiple queries. We're going to query a user by ID, query a user by location, querying users by email. And we will also look at a mutation wherein we'll update something now, wherein we'll update like a location for a user and see how it goes. And as we saw in the first example, we again have a strongly typed data schema. In this case, it's a simple user schema wherein we conform it to different values, different entities as a part of the user. And we have simple functions written in to execute our queries. So we have get user wherein you're filtering user by ID, and we'll see the demo on how things get entered in or how they get executed as a part of the query itself. And just going apart from the queries, so these are like different, the way you define, sorry, the way you define these different queries is like creating different routes in Rest, wherein here we have different queries in GraphQL with like users by email, users by location, and getting a user by ID. And the important thing to note here is we have to use app.use using like a slash GraphQL, which is like the single endpoint that I talked about previously in the slides. GraphQL has a single endpoint. So you're getting information back from that single endpoint, and you conform it to a proper schema. GraphQL HTTP takes care of that. You're passing in the schema that you created above. And GraphQL True helps you with the GUI version of GraphQL, wherein we're visualizing these queries and mutations that we're running in on the web browser. And we're just like listening in on port 4000 that we specified previously. So let's start this again. Let's start node example 2.js. App is listening on port 4000. So in the second example, we have query auto documentation already done as a part of GraphQL, which is the nice part. We have three queries in here, wherein we're querying a user by ID, querying a user by location, querying a user by email. And we also have a mutation in here, wherein we're updating a user by location. So let's try to run these queries. So before I do that, we see like a different syntax out here, which is like ... user fields. Now this is something new. And this is nothing but like a fragment in GraphQL, wherein we're trying to run information, we're trying to get information about users, and we are going to have to say copy paste entire things like first name, last name across all our queries. So what GraphQL does is it creates like a reusable thing, wherein it's called a fragment. So this fragment helps us to be reused across different queries. And that's why we're using ... user fields, because it's a fragment user fields on type user. So let's try to execute this query now. And as a part of like, this query, we have an integer that needs to be passed as a part of our arguments. And the exclamation point behind, like besides int, means that you have to pass something to execute this query. This argument is a required argument. And as of now, we'll just try to pass, say, 75 maybe. Let's try to execute this query. We get information back from the dataset that we had on our 75th user. Now say you wanted to maybe get information on multiple users. So this query takes care of that, wherein we can pass multiple users to this query. So we have user one at 75. Let's also try to add another user. I'm adding a user to say maybe 44, for example. And it gives me information back for two users now with just one single query. Now, if I wanted to get information on more users, I could add them out here. And I will just be copy pasting this. And I'll pass another user. Maybe 3. And now I have information on 3 users being returned back as a part of my query. The next query that we see is getting users by like a certain location. So say you have a requirement wherein you need locate users located in a certain area. So this query will take care of that. As a part of this query, we have a location, which is the argument that we need to pass to the query. And the argument uses a string entity. It's a required thing. The exclamation takes care of informing you that it's a required thing as a part of your execution for the query. So we're going to pass it a location now. Say we need all users who are in China. And we're executing this query. executing it, it returns us back all the user data for users who are located in China. Now, say for example, you are getting this information, but you just don't need information on gender and first name, last name. What you can do simply is update your fragment, and you can just have information on, say, employer job title, and their employer identification number, and re-execute the query now. With the simple re-execution, you can see how easy it is to just get like top selection of data from your GraphQL endpoint. We just tried to remove the things that we didn't need and just get the data for what we needed. And it was easy to do that just by like updating fields in the schema that you defined previously. The next query that we'll try to execute is maybe get like a single user by email. Sorry. I'm going to run that same query again just to get an example email. Oh, sorry. So I'm going to just pick some random user. I can just pick up this email. So I'm running get single user by email, wherein I have to pass something like an email, which is a string required field, and I'll get a user by email with like the different user fields. So I'm going to pass this email when I try to run this query, and it should return me Lenny Probert as a part of this query. Just running that query, I get that person that I wanted previously, and it's so easy to just like create separate queries for things that you need. And all of this is hitting a single endpoint, which is /GraphQL. Now let's look at this mutation. We need to change some data as a part of a user object. So I'm just gonna comment this out so that it's not going to execute the other things. And as a part of this mutation, I need to pass like an ID and a location to update users in a location. So I'm going to update, say, ID. Let's update this person 5, which we know now. This person is in China. Let's update their location to say Spain, maybe. So I'm going to run this mutation now. It should update the user for me. And as you can see, an update is so easy to perform, wherein we updated Glenny Probert, who's a dummy user in this case, changed the location from China to Spain. Now, just to verify this, the mutation ran correctly. We saw the data coming through, but I want to just do a sanity check on if the user was updated actually or not. Sorry. So let's try to run this get user by ID query again, wherein we are going to query the same user and see if their location was updated. The variable name is called user, not ID. And we do see the location is Spain now based on the update that we passed in previously. So as you can see, it's so easy to make like a mutation or a query in GraphQL. All it takes is a couple of functions which can resolve like certain arguments that you pass through. And it's pretty easy to like run mutations and functions on the fly, especially when you have nice documentation coming through as a part of GraphQL. And going back into the slides now. So we talked about a lot of different things, and we talked about what GraphQL is, what it is not, common misconceptions, different benefits, and just wanted to give a key takeaway before we can like, actually jump to using GraphQL. I mean, both REST API development and GraphQL are useful depending on the need, and both have their advantages and disadvantages. I mean, we have seen that GraphQL is gaining popularity because of its no over and under fetching abilities. It does offer like efficient collaboration mechanisms for client-side applications. It's very powerful, and it's really helpful when you're developing, say, mobile apps, for example. It's definitely a tool to like achieve like specific query oriented goals, but it shouldn't be thought of as a solution for like say all API related challenges. And it shouldn't be considered like a replacement for REST. I mean, you could have applications which can coexist with REST, or you could like mimic certain ways wherein you could have a GraphQL API for some of the REST things that you want to do. So it's not one or the other, or it's just not like this is going to replace REST. It should be thought of as a specific tool to achieve query oriented goals and like an alternative instead. If you enjoyed this session and if you want to learn more about GraphQL, you can like, check some of the resources. The GraphQL site itself is a great site to start with. They have a nice community as well with different Discord channels. And if you just want to play with some GraphQL APIs in say GraphQL, you can play with some of the public APIs out here. And yeah, there are a lot of public APIs that you can play and like just create queries or mutations and just test some of the GraphQL knowledge that you gain via this session. Yeah, that's all I had from my side today. And thank you so much for attending. Any questions?